Good morning, everyone. Unfortunately, since beef steers do not lactate, we won't be talking about milk production now. But before I start, as outlined in the slide, today in my presentation I'll be following the scientific methodology. So the optimization in relation to what's being fed to the animals, in relation to what's being produced, is one of the many ways that we can improve efficiency in livestock production systems. It's also important to highlight that this optimization between inputs and outputs may also bring a couple of benefits, such as lowering our footprint in the environment, as well as increasing production profitability. Because of that, there's a great interest for the beef cattle industry to improve efficiency of feed utilization. But there's a primordial question that arises with this, which is fairly simple but still usually gets us, which is how do we actually define efficiency? And in fact, there are many ways and many measures that we can assess biological efficiency, and this table is representing a couple of those measures that can be used in beef cattle systems. In our study, we looked at 3 different measures of efficiency, such as gain of feed, residual feed intake, and residual gain. But another thing to keep in mind is that the definition of the term efficiency will vary across the different life cycle from beef production. For instance, what's expected as an output of interest from a finishing steer will be completely different from what we expect from a cow-calf operation. So that's really important to keep in mind. So to date, we haven't yet completely elucidated the biological basis of feed efficiency. And of course, there are many factors that could be influencing this biology. But for example, we've been trying to optimize animal size in relation to optimal production for many years. And this is very important since animal size has huge impacts on both economical and biological efficiency. But more specifically, linear body measurements may also provide insights into the changes in maintenance energy requirements, the surface area, as well as gut capacity. Other things that have been experienced increased interest are feeding behavior and activity, since those two have a potential link to feed efficiency. And in fact, previous research has shown that efficient phenotypes have been associated with less daily activity, having smaller and longer meals, and also devoting more time to rumination processes. Another thing that could be signaling those differences in energy use are through metabolites, in which we can include metabolic ions, compounds, enzymes, and even hormones. So basically, any metabolite that is associated with those energetically demanding functions could be signaling those differences in energy use. In our study, we looked at plasma urea nitrogen, non-stearified fatty acids, and glucose. And lastly, it is well known that there are different energetic requirements for deposition of fat and lean tissues. Therefore, if we study body composition in the context of feed efficiency, we might be elucidating that physiological basis a little bit more. So, if we consider those energetic links between animal size, feeding behavior, plasma metabolites, and body composition, it is reasonable to hypothesize their relationship with feed efficiency. Additionally, that association might differ according to the different efficiency measure that you use. So our objective here was to evaluate the association between those traits with gain of feed, residual feed intake, and residual gain. And to do that, we had a steer experiment being conducted in which we had 62 animals that were tested over a 112-day period. Those animals were housed at the Beef Cattle Research Complex at North Dakota State University in Fargo, North Dakota, and they were equally divided into 2 pens of that gave access to the animals for the Inzentech automated feeding system. Those animals were fed a corn-based diet. And as for the timeline of the experiment, on both initial and final days, we had a 2-day body weight assessment in which we measured the animals as well as collected blood. And every 28 days, we had a body weight assessment as well as blood collections. At about 2 months after finishing the feeding trial, the animals were sent to a commercial slaughterhouse in Nebraska, in which we had access to the data collected by trained personnel. So our gain of feed ratio was calculated as the ratio between average daily gain and dry matter intake, residual gain as the difference between observed and predicted average daily gain, which was based off of midpoint body weight and dry matter intake. And similarly, residual feed intake was calculated as the difference between observed dry matter intake and predicted dry matter intake, which was calculated based off mid body weight as well as average daily gain. So, as illustrated in the images here, we had 6 different linear body measurements which included heart girth, mid-girth, flank girth, hip height, body length, and hip width. And for feeding behavior, we considered a meal each feeding event that possessed an interval no longer than 7 minutes, and a visit any time that the animals had access to the feed bone. So for feeding behavior traits, we evaluated about 7 different traits. Our plasma urea nitrogen, non-sterified fatty acids, and glucose were measured using the STATA procedures along with commercial kits. And for our statistical analysis, we conducted a correlation analysis between animal size, feeding behavior, plasma metabolites, and the body composition traits with both productive performance and feed efficiency measures using the METABOLITES statement of the GLM procedure. And in order to verify the overall contribution of those traits along the 3 different measures of efficiency, we did a partial regression analysis. So starting off our results in discussion, this table is representing the correlation coefficients between the productive performance traits and efficiency measures with all the animal size traits. So we can see that the positive associations between all the animal size traits with body weight, average daily gain, and dry matter intake is once again reinforcing that high association of animal size traits with eating capacity of the animals. But I would like to have your attention focused on the highlighted column that is showing the negative associations between gain of feed and all the animal size traits. And also note that there is a lack of associations between animal size and residual gain and residual feed intake. So that becomes a little bit more interesting when we plot the results from heart girth across the 3 different measures of efficiency. And if we focus here on the top left image, we can see that animals that gained more, measured through the gain of feed ratio, possessed a smaller girth. Now, when we try to look for this association or even an opposite relationship in the 2 other different measures of efficiency, we can no longer see that. We can see that the lines go flatter and our R-squares are basically 0. So, which means that baby animal size traits are not associated with those 2 measures of efficiency. And most likely, since we account for body weight in that prediction model, we might already be accounting for those differences in size. Now, when we look at feeding behavior results, we also verified a positive association between meals per day and visits per day with residual feed intake. Those results are following the previous literature in which they suggest that more efficient animals would have a lower number of daily feeding activity. But what's interesting here, and it's also highlighted at the bottom, are those contrastingly associations between residual feed intake and the amount eaten per visit, and gain of feed with the amount eaten per meal, that altogether they might be indicating that animals, regardless of the efficiency measure, that perform better, they would have a lower amount of meal consumed, and somehow they would still compensate that by performing better. So in relation to body composition, we found a negative association between marbling and gain of feed, which could be somewhat related to the first results that we showed with the high association of gain of feed with animal size measurements. And that association could be perhaps explained that if an animal that had a lower average daily gain and an increased marbling could be solely due to a size issue. But now, surprisingly, we had no differences when we look at residual gain and residual feed intake. And to some extent, those results follow the previous literature, but they also are in contrast to some of the literature, which proposes that efficient animals might deposit a higher percentage of lean tissue in comparison to fat, which shows the importance of body composition in the context of feed efficiency. For plasma metabolites, we found a negative association between non-sterified fatty acids with body weight and dry matter intake. Again, those relationships are following the results that we have in the previous literature, and interestingly, we found a positive association with NEFAs and gain of feed. And once again, once we plot those results, we can see that potentially animals that gained more possessed a higher concentration of NEFA. And if we think in the context of growing animals, this is a very interesting result, since a higher availability of NEFAs in growing animals may be representing a higher energy delivery to peripheral tissues. And just to contrast with the previous study we conducted, we also saw that efficient heifers measured through RFI presented consistently higher concentration of NIFA throughout the experiment, which could further support that hypothesis. So now there are a couple things that we can talk about with those traits' overall contribution to the measures of efficiency. And first, in the pie chart related to gain of feed, we can see once again reinforcing the importance of linear body measurements in the context of that specific measure. Now when we look at residual feed intake, we can see that feeding behavior had a really important contribution for that specific efficiency measure. And now, in relation to residual gain, there are two things that we can say about this measure. The first is that clearly residual gain and residual feed intake are two completely different measures. The second, which is fairly a little bit more obvious, is that potentially what's driving intake is completely different than what's driving gain. So therefore, we should definitely look into other traits to see what's driving that difference. But overall, for conclusions, we can conclude that first, gain-to-feed ratio is highly dependent on animal size, in contrast to the measures of residual gain and residual feed intake. That feeding behavior trait may play an important role in the variation of residual feed intake, and that overall fat metabolism, either by a higher energy delivery to peripheral tissues or depletion of body reserves, may constitute a really important physiological process in the context of feed efficiency that definitely deserves further investigation. And I think the take-home message with this study is that regardless of the efficiency measure you use, the selection criteria based on efficiency measure should definitely take into account animal stage of production and overall outputs of interest from that system. Since there's not a right measure of feed efficiency, there are different situations in which you could apply those measures without bringing any detrimental effects to overall productivity. So with that, I'd like to thank all the support that I received during this experiment, as well as the travel award granted by the American Society of Animal Sciences. I'd like to thank your attention and be happy to entertain you with any questions you might have.
Thank you, Ananda.